I'm going for lecture number 2. Network Protocol Security. So in the last lecture, that means in yesterday's lecture, we discussed about the basic things. What is security? What is the primary objective? Okay, the primary objective of security. That means confidentiality, integrity, availability. Then we discussed about the threats. What is a threat? What is an attack? What are the difference between this? Then we discussed about the model, network security models. Okay, 3 different models. Then some technologies, security solutions we discussed. So it was just an introduction. Okay, just an introduction. Now today we are going to discuss about network protocol security. So this is lecture number 2. So in this lecture, we are going to discuss about what is a network protocol, network protocol specifications, network standards, TCP/IP and OSI layers, a comparison. Then we are going to talk about the packet generation. The next topic is crypto placement at different layers. So in different layers of OSI model, we can have the cryptography. We can place the cryptography. So that we are going to discuss. Then protocol addressing and then protocol headers. So these are the major topic we are going to discuss. As I already told, computer security students, only first lecture will be same. Okay, it is not exactly same, around 60 to 70% it will be same for network security and computer security. But starting from the second lecture, okay, it will be entirely a different concepts. Here we are going to talk about how to protect the data in a network. Okay, how to protect the data in the network. The data is moving from one place to another place. Data is moving across the layers, starts from layer 7, layer 6, layer 5, layer 4. So the data is moving like that. Then finally it is reaching another computer, and in the other computer also, okay, it is going to move from layer 1, layer 2, layer 3 like that. So how to protect your data in this? So that is a concept we are discussing here in this course. Okay, network security we are discussing. Okay, so these are the major topics that we are going to cover in this particular lecture. Now, let me start with the first one, network protocols. So the basic definition. What is a protocol? There are so many protocols available. Okay, so what is a protocol? The protocol means a set of rules. A set of rules to be followed by all those who are participating in a network. Okay, for example, my computer. I'm having my computer. So my computer is now connected with your computer. You are just listening my voice, my audio, video, everything. So my computer is connected with your computer. Now, in this case, a set of protocols running in my machine, the same set of protocols should run on your machine also. So then only these two machines can have a proper communication. Suppose if they are having a different protocols, then these two machines, they cannot communicate with each other. Okay, so protocol means some set of rules, some set of functions, okay, or standards which must be followed by everyone in a network. So that is called the protocol. Okay, you can see network layers, different layers. There are 7 layers available. If you take OSI model, there are 7 layers available. If you take TCP/IP model, okay, 5 layers or 4 layers available. So depending upon, okay, in every layer, okay, there are different set of protocols running. So these protocols are designed to provide a set of functions that are defined by a standard. So that means the protocols are going to provide some set of functions to us. Protocol standards are created. There are some standards available, some regulation about standards also we are going to see in the coming slides. There are some standards available. So these standards are created and maintained by different groups. What are the different groups? Means they are called professional bodies. Okay, like IEEE, ISO. So there are different groups available. They are creating some standards. So they are the international organizations or the professional societies. Okay, they are giving some standards. So we have to follow. Everyone must follow the particular standards. So what we understand from this slide means, what is a protocol? Protocol means it is a set of rules, okay, that every host or every computer in a network is going to follow that. And there are some standards. Okay, there are some standards available. So these standards are created by some groups. What is a group means? Starting from international organizations to the professional societies, professional bodies. So what are the professional bodies? We are going to see. Okay, in the coming slides we can see. Okay, so this is regarding the network protocols. Now, network specifications. Sorry, protocol specifications. So if we take protocols, we can divide the protocols into two groups. Okay, majorly there are two groups available. What is that? The first one is called open protocols. Then the second group is going to be closed or proprietary protocols. Okay, so open protocols, proprietary protocols. Okay, what is this open protocols means? The word itself, it is very clear. Okay, make it very simple. The open protocols will be openly available. It is developed by some group of peoples, some group of peoples. So anybody can, okay, download, you can use it, and you can see the design of that. Okay, you can see the design of that particular protocol. Okay, and even you can do some modifications in that. So that is going to be the open protocols. But if it is a proprietary or closed protocols means, these protocols will be designed by a particular, okay, company, an organization, a particular vendor. Okay, for example, Cisco. So the protocols developed by the Cisco, we cannot change. Okay, we cannot change. We have to only use the protocols. So these protocols are called proprietary or closed protocols. So in the proprietary or closed protocols, you will be having some restrictions. Okay, it will be having some restrictions. You cannot do any changes in that. You cannot do, okay, modifications. Simply you have to use it. But in the open protocols, okay, there will be some chances available. You can see the design of that. Okay, you can see the code, okay, of that, and you can do some changes. You can modify that. You can customize that. Okay, all these things are possible. Now, let us see, okay, in the slides, open protocols. So most network protocol standards are open. So most of the network protocols are, okay, it is a open protocols and subject to many rounds of review. So you might have heard about the RFC, request for comments. So they will introduce some protocols to you. So the users can use that and they can suggest, okay, some issues, some suggestions they can give. So based on the suggestions, they will improve the protocol and then the next version of the protocol will come. So a protocol standard, if it is open means they subject to many rounds of review. They will, okay, review and finally, okay, the final product, okay, the protocol will come. So this should lead to a robust protocols with minimal design flaws. So these protocols are very strong and there will be less, minimum design errors. So the requirements for most of these protocols are to implement a particular set of functions. So what is the use of these protocols means to do some set of functions and security is not a requirement. Security will be less. If you are going for the open protocols, okay, the security will be less. That is a very important point. So one side effect of the open protocol, if you see the open protocol, it is easier to discover the security flaws. Design will be good. The design will be good. The design will be very strong. It will do a lot of functions. But if you see the security, there will be some security flaws. Errors will be available in these protocols. So Open protocols are very strong. They are robust. Robust means strong. They can do lot of functions, functions they will do. But as far as security is concerned, in the open protocols, the security is very less. Okay, so this is the point. Now, I'm going for the closed or proprietary protocols. So closed or proprietary protocols, this is a vendor based. Okay, there are so many protocols available. They are multiple vendors need to interoperate. That means it is completely vendor based. So vendor means a particular organization. Okay, they will make. Okay, for example, Cisco. If you go for Cisco, in Cisco there are a lot of protocols developed by Cisco itself. So it is okay. Some protocols developed by them. We have to use only that protocols, Cisco proprietary protocols. So here, a individual organization, okay, the vendors will take care of everything. So the proprietary protocol is more difficult to discover the security flaws. This applies both the attackers and the user. That means proprietary protocol are very secured. It is very secured. They make the protocol very strong. Users cannot do any changes in that. You will be having lot of restrictions. Okay, proprietary protocols are reverse engineered within a short period of time and do not deter the attackers. So for attackers, it will be a challenging one. Okay, so proprietary protocols secured. Okay, this is the point what you have to understand. Open protocols are vulnerable. Proprietary protocols or the closed protocols are secured. Okay, so this is what the point we have to understand. So this is regarding the network protocols. Now, let me go to the next one. The next concept is network standards. Standards and standards organization. Okay, now let me talk about the organizations first. Okay, let me talk about the organizations. Then I will I will explain what is a standard. Now you can see there are so many organizations available. You might have studied about this in many courses. So the first very popular organization is American National Standard Institute, ANSI, Ansi. This is one of the very popular standards organization. Okay, note down. Now, in the next slide, you can see the another organization is IEEE, Institute of Electrical and Electronic Engineers. Multiple choice questions. IEEE stands for what? ANSI stands for what? Then you can see the next organization is International Standards Organization. These are all some of the notable standards organizations which are available in the IT. Okay, in the IT and also in the networking, for networking. So they created so many standards. Then the next one you can see International Telecommunications Union, Telecommunication Standards Sector, ITUT. So you might have heard about this in many courses. Then the next standards organization is Ietf, Internet Engineering Task Force. So only 5 standards organizations we are giving, okay, in these slides. But if you see the list, okay, if you go and search in the internet, so you will get a very big list. Okay, a very big list of standards organization is available, but we are taking only 5 here as an example. Okay, so we'll see. Now I think you might have understand what is standards organization. So these organizations, they are fixing some standards in different areas. Okay, for example, if you take ITUT, they fix some standards in the cables, communication related things. In IEEE, there are so many protocols available based on that. Okay, so every standards organizations, so they are giving a different standards in a different domain. So people, we are following that. We have to follow that. So we'll go one by one. Okay, now let me go for the last one, IETF, Internet Engineering Task Force. So what they are doing, what this organization is doing means they develop standards for the internet and consist of members of various organizations in a open and any persons that has the interest. So they fix some standards for the internet, some internet related things, some internet related protocols. They are fixing the standards. Then ITUT. So here this is completely based for the communication. So this is a group created by the United Nations that creates standards primarily for the phone system, for the communication system. Okay, like cables, communication protocols. So there are so many things they are taking. ITUT, they are completely based on the communication related standards created by them. Then ISO. So ISO, this is available. This organization is available worldwide. So they fixed some, okay, even OSI model. You know about the OSI model. Today we are going to discuss about the OSI model. So OSI model was proposed by ISO. Okay, ISO OSI model. So they are providing some standards in some areas. Then IEEE, this is a very popular standards organization. So it is one of the international professional body. Okay, even I am a member of IEEE. Okay, I am the member of IEEE. So IEEE is an international professional and society that create international standards in many different areas. Okay, starting from wireless, there are so many things. Okay, 800 project. I think you might have heard about it. There are a lot of standards. Okay, most of the standards nowadays, okay, it is created by the IEEE. Then the next one is Ansi, American National Standards Institute. So this is a private organization whose membership is made up of the professional societies, government groups, and other associates. Okay, all private professional societies, government, everybody they are okay member of American National Standard Institute, and they develop lot of standards. Okay, to help the groups compete in the global market. Okay, Ansi is fixing lot of standards. Okay, related to some programming language also. Okay, C programming. You might have heard about the C programming, Ansi C. Okay, so these are all the standards organizations. Okay, now what is a standards organization? What they are doing means they producing the standards. They producing the standards or maintaining the standards to address the need for the groups of the users. So they are creating the standards. Why we need this standards organization? Okay, just think why we need this means if you have some standards means then only everybody can communicate with each other. Okay, for example, I am following my own standard. You are following your own standard means our two machines cannot communicate with each other. In my machine, there should be 7 layers. In your machine, there should be 7 layers. Then only my machine and your machine can communicate with each other. Suppose you are following the OSI model. I am following a different model. Okay, in my machine, I am using a different model means these two machines, they are not going to communicate with each other. Okay, you take cables. We are all using the cables. Okay, a common type of cable we have to use. That should be, okay, 8 wires, 4 pairs. Okay, wire 1, wire 2, wire 3, wire 4. There are 8 wires available in the cable. That means in the UTT cable. So my cable and your cable should have the same standard. Then only we can communicate with each other. So the standards, what is the use of the standards means they will maintain or they will manage and they will try to make everybody using the same type of products. Okay, they fix some common rules. So everyone should follow that. Otherwise, okay, there won't be a communication will be failed. Okay, people cannot communicate with each other. Okay, so this is the main thing of creating the standards. Not only that, some standards, they will fix some law, some rules. You have to follow that rules, the rules and regulations. So if you are not following the rules and regulations, you will not get that particular service. Okay, so these are all, okay, this is called the standards and standard organizations. There are so many standards organizations available. Ansi is an example, IEEE is an example, ISO is an example, ITUT is an example, Ietf is an example. So this is about the standards organization. Just we are giving an introduction only, okay, about the standards organization. Now, I'm going for the next topic. So the next topic is TCP, IP and OSI layers. TCP, IP versus OSI layers. Now, I'm just going to the next slide to show you the layers. If you take the OSI model, so this is proposed by the ISO standards organization. We discussed in the previous slides. So in this layers, that means in this model, in the OSI model, there are 7 layers available. Okay, there are 7 layers available. So the first layer is physical layer, data link layer, second layer. Third layer is a network layer. Fourth layer is a transport layer. Fifth layer is a session, then presentation and application. There are 7 different layers available. So this is fixed by a standards organization. Okay, what is the name of the standards organization means? That is the ISO. They fixed. Okay, so I'm going to follow it. Now, about each layer, you might have studied about in the previous courses. Okay, in the data communication course. Okay, what is the physical layer is doing, data link layer, network layer. Okay, all the functions you might have already studied. But I'm just going to talk about the important things. Okay, so if you take the physical layer is going to be your cable. Okay, that is layer 1. So this layer you can see, you can touch. Okay, so it is going to be a physical devices. A cable will be available. So this is one machine. I'm connecting one machine with another machine. Okay, this is another machine. Okay, there are 2 machines available, sender and receiver. So in the sender machine, there are 7 layers available. In the receiver machine also, there are 7 layers available. Now, you can see physical, data link, network, okay, transport, session, presentation, application. The same thing I'm going to have it here. Now, if you come to the TCP IP model, in the TCP IP model, what they did means the first 2 layers they merge together and they are going to call it as application layer. Actually, in some books, if you see, the first 3 layers merged together as application. In some books, you can find there are only 4 layers available in the in the TCP IP. In some books, okay, it will tell 5 layers for you. Okay, so but the concept is same. Now, the first 2 layers are merging together here as an application layer. Then the next 2 layers merged as TCP layer. Network layer, we are taking it as same thing. Then in some books, actually, both this data link and physical will be merged together. Okay, it will be merged together. Okay, we have a single layer. Okay, so it may change from author to author. So you can refer it in some books, but we'll follow this. Okay, whatever available in this slide, I will follow it. Now, the first 2 layers merged together, application. Session and transport merged together, it is a TCP, or we can say it is the transport layer. Here network layer, okay, this is the internet layer, okay, or we can say it is IP layer. Data link, physical. So what we are understanding from this means in OSI layers, okay, there are 7 layers available. So whereas in the TCP, we have 1, 2, 3, 4, 5. So 5 layers available. Okay, so this is the concept. Now, about every layers, we are going to summarize. Okay, we are not going to explain everything. Okay, only summarize. Okay, we are going to summarize about the each and every layer in the next 2 slides. Now, so let me go to the application layer. So application layer, it is a layer 7. So in the application layer, you are going to have your data. Okay, or all your application programs will be running. So examples, okay, you can see the examples like your browsers, your email software, or file transferring software. Okay, whatever you are seeing, the PowerPoint presentation you are seeing from my machine. So this is layer 7. The PowerPoint presentation, what you are seeing now, that is the layer 7. So all your applications will be running. Okay, all the applications will be running. The users are going to communicate with the application layer. I am communicating with the application layer, and after that what is happening I don't know, but it is reaching your computer. So in your computer you are seeing the application layer. In my machine I am seeing the application layer. So what is happening in between we don't know, but it is reaching you. Okay, it is reaching you. So application layer, it is the layer 7. This is the layer interface between the application and the network programs. So it is going to be an interface between the applications and your network. Then there are a lot of application programs. Example, browsers, email software, okay, file transferring, login, okay, even PowerPoint, what you are seeing now. So these are all examples for application layer. Then from the application layer, the data is moving to the presentation layer. Now, in the presentation layer, the presentation layer is responsible for encoding and decoding, encryption and decryption, okay, and it is going to deal with the data formats. Okay, for example, okay, like voice data, text data, video data, how to convert this data. So all these things will be taken care by the presentation layer. Some data should be encrypted, some data no need to be encrypted. So everything regarding the data formats, dealing with the data. So this will be taken care by the presentation layer. Okay, you can see responsible for dealing with the data that is formed differently, allows the application layer programs. Okay, that means application layer programs are creating the data. Okay, application programs are creating the data. So this data will be handled. Okay, that means the data formats, encryption, decryption, encoding, decoding. Okay, even sometimes compress. The data should be compressed. Okay, so everything will be done by the presentation layer. Then the next layer is a session layer. So this layer, this is responsible for creating, managing, and closing a connection, a communication connection. So this layer is used for creating the connections. It is dealing with the session. Session means like a session is initiated. So now my machine and your machine is connected. So the session is established. So the session is live. Session means a period, a duration. It is live. Suppose if there is any problem in your machine, means this session will be closed. Again you have to connect. Okay, again you have to connect. So session layer is responsible for creating, managing, and closing a communication. Okay, a connection. Okay, a connection or a communication connection. So this is about the session layer. Then the next layer is the transport layer. So this layer will provide end-to-end connectivity. So this layer is responsible for providing the reliable connections. It is responsible for providing a reliable connections such as packets. So it is going to send the packets, okay, traffic control, congestion control, okay, any collisions. So all these things will be taken care of the transport layer. Network layer, this is responsible for routing the packets, responsible for routing the device, independent packet from the current hop to the next hop. Hop means here router. From one router to another router, your packet should move. So I am sitting here, you are sitting somewhere, but the packet will come through so many routers. So the routing will be taken care by the network layer. Data link layer. So the data link layer, this is the only layer in which you have sub layers. Sub layers. What are the sub layers? Means logical link control and media access control. Okay, LLC, logical link control. This is a sub layer. And MAC, media access control. So these two sub layers available in the data link layer. And this layer is responsible for encapsulating the device independent data packets into the device independent frames. I'll come to that later. So this layer is going to deal with the frames. Okay, it is going to deal with the frames. Then the last layer, it is the physical layer. So here everything will be converted into zeros and ones. Okay, this is a physical cable. Okay, a physical cable. So here your data will be converted into electrical signals, or it will be converted into zeros and ones, and it will be transmitted. Okay, the packet, or the data will be transmitted. So this is about the 7 different layers, but I want to give you a very important thing here. You have to keep this in your mind. So what does that means? So kindly please note down. Okay, application layer, presentation layer, session layer. So in these 3 layers, okay, that means the data will be in the form of data. That means your data will be available without any change. Then the next layer is the transport layer. So in the transport layer, the data will be converted into segments. So these keywords you have to keep it in your mind. Then the next layer is a network layer. So in the network layer, your data will be converted into packets. So the next layer, data link layer. In the data link layer, the packet will be converted, all the packets will be converted into frames. Then the last layer is a physical layer. In the physical layer, the frames will be converted into bits. Okay, that means it will be converted into zeros and ones. Now, if you take the transport layer, in transport layer, you will be having port numbers. So the port numbers will be used. Okay. So what is the length of the port numbers means? 16 bits. In the network layer, what type of addressing? Okay, we'll be using means we'll be using the IP address. So IP addresses will be used here in this particular layer. You can use either IPv4 or you can use IPv6. So anything you can use. If you go for IPv4, it is going to be 32 bits. The length is going to be 32 bits. If you are going for IPv6, the length is 128 bits. Okay, it is 128 bits. Then, in the data link layer, what type of address is used means this is the MAC address. The MAC address will be used. What is the length of the MAC address? The length of the MAC address is 48 bits. This is a very important thing. So you have to remember. Okay. So port numbers are used in transport layer, network layer, data link layer. So in every layer, what are the addresses? What type of addresses we are using? Means, so in the transport layer, we will use port numbers. In the network layer, we'll be using the IP address. In the data link layer, we'll be using the MAC address. Okay, so this is a very important thing. So everyone should keep this in your mind. Please copy it. I'm just giving few minutes. Please note down somewhere. Okay. Now, I'm moving to the next slide. Okay. So this is about slide number 10, 11, 12. Okay. This is about the layers. Okay. So the layering concepts, you must know the layering concepts there. So the next one, I'm moving to the next topic. It is a packet generation. Okay, so packet generation. So this is we are going to discuss now. Okay, if you see this diagram, so you'll be understanding very clearly. So application layer, this is the topmost layer, that means the layer 7. So here the data is generated. You can see the data block. Data block. Now, so with this data block, okay, okay, let me go to the previous slide. I will explain by using this. Okay, it will be more comfortable for me. Now you see, so the data is available here. Okay, now the data is coming to the transport layer. Okay, the data is coming to the transport layer. Now in the transport layer, so what the transport layer is going to add means it is going to add a transport layer header. A transport layer header will be added, plus the data will be taken. So the data is coming from the first 3 layers. Now the data is maybe encrypted, okay, or the data is compressed, okay. So because the presentation layer is doing that. So the presentation layer will take care of the format, the data format. So you just take it. It is a compressed data and it is encrypted data. So we no need to worry about it. It is data for me now. So with this data, the transport layer is going to add a header. It is going to add a header, TCP header. Now, so this one I'm going to say, okay, I'm going to call this as a segment. Okay, I'm going to call this as a segment. Now, so with the data, a TCP header is added. So what is available inside the TCP header means source port number and destination port number will be available. In the TCP header, okay, in the TCP header, port numbers will be available, source port number and destination port number. You will understand this in the next class. Okay, I will show you the lab. Okay, in the lab, using packet tracer, I will show that. Okay, so the source port number, destination port number, everything you can see. Now, so TCP header, in the TCP header, we have the source port number and the destination port number. Okay, will be available. Now, this one I'm going to say as segment. Okay, so this is going to be the segment. Now, the segment is coming to the next layer. Okay, it is coming to the next layer. So in the next layer, so what I'm going to do means you can see already TCP, okay, header is available, plus data is available. Okay, this is already available. Okay, we received from the transport layer. Now, in this layer, again a new header will be added. So that means the IP header will be added with this. Okay, the IP header will be added with this particular segment. Okay, now you can see. So this is going to be like this. So this is what we already received. We received from the previous layer. Okay, so in this layer, a IP header is added now. What is available inside the IP header means inside the IP header, you will be having the source IP address and destination IP address. So you will be having the IP address now. Now, the whole thing now I'm going to call as packet. So this is known as packet. This is called packet. Okay, this is called the packet. Now, the packet is going to the next layer. Now, what I'm going to receive, okay, I just copy this. Now see, the whole thing I'm receiving. That means I receive the IP header. Okay, so this is what I'm going to receive from the above layer. Now, this is, okay, with this, your data link layer is going to add, okay, a new header. So what does that mean? So it is going to add Ethernet header or data link layer header, anything you can say. So now I'm going to say it is a Ethernet header. It is going to add. Now, what is available inside this Ethernet header means source MAC address and destination MAC address is available. Source MAC address and destination MAC address is available inside this. Now I'm going to say this. This is called a frame. This is, I'm going to say this is a frame. Okay, this is called a frame. So different names. Okay, you see the data is available here. So data is encrypted or compressed or okay converted into different. We no need to worry about it. That is data. I'm taking the data in the layer 4. With the data, okay, I'm adding the transport header. Then next IP header will be added. Next data link layer Ethernet header will be added. Now this frame will be converted into zeros and ones. Okay, it will be converted into zeros and ones and it will be sent. Okay, and it will be sent. Now, so this process, okay, that means from layer 7, layer 6, 5, 4. So this process is called encapsulation process. This process is called encapsulation. So encapsulation means every layer will add something. Every layer will add a cover. It will add a header. Okay, that is called the encapsulation process. Now, if you go to the next slide, you can understand it very clearly. Okay, all of you see this. Okay, this is the data block. That means your data. So it is coming to the TCP layer. TCP layer means it is a layer 4. Transport layer. So in the transport layer, they add the TCP header they are going to have. Already the data is available. So with the data block, a header will be added. Then this will be given to the next layer, IP layer. In the IP layer, you can see I take this data block. Okay, now this is called a segment. This is called a segment. Now I'm giving it to the next layer. So in the next layer, you can see here data block is there, TCP header is available. So with this, I'm going to add a IP header. IP header I'm going to include. So in the IP header, okay, after including the IP header, now I'm going to say this is the packet, IP packet. Then I'm giving it to the next layer. So in the next layer, you see, I take the data block, I'm taking the IP header, okay, sorry, TCP header, IP header. With this, I'm going to add one more header. I'm going to add, this is called the frame header, frame trailer. Okay, they had, okay, at the beginning and also at the end. I explained only in the beginning to understand. So frame header and frame trailer, so they add, now this becomes a frame. Okay, it becomes a frame. Now, the frame is now a sequence of medium signals. Now, this will be converted into signals and it will be sent in the cable, in the medium. So, this is called, okay, packet generation concept. So, how, okay, the things are coming in every layer. So, this process, this entire process is called encapsulation process. Okay, you can see the word encapsulated. This is called the encapsulation process. Okay, so every header, if you take the TCP header, there are so many fields, so many other fields available. If you take IP header, there are a lot of fields available. If you take the form header, that means the frame header, that means the Ethernet header, there are many fields available in that. About that, we are not studying, but we are understanding, we need to understand the process of encapsulation. Okay, so this is called the encapsulation process. Okay, now let me go to the next topic. The next topic is crypto placements. Cryptographic algorithm, encryption algorithm, where you can place, where you can keep. Okay, in which layer you can have means in different layers you can keep the encryption. You can do encryption in different layers. Okay, for example, in the application layer, okay, you can implement or you can have the cryptographic systems or cryptographic algorithms. In the transport layer, you can have the cryptographic systems. Then, in the network layer, you can have the cryptographic systems. Then, in the data link layer, you can have the cryptographic systems. So, in different layers, you can implement, okay, you can place the cryptographic algorithms in different places, in the different layers. Okay, now let me go to the data link layer. In data link layer, what is available? We have frames. In the data link layer, we have frames. I am in layer 2 now. Okay, we have frames. Now, these frames we can encrypt. We can encrypt. So, you can encrypt the payload of the frame. What is the payload of the frame? Frame means, now you see, I'm just writing here. Okay, so Ethernet header. Ethernet header, I write EH. Ethernet header is available. Okay, it is added. Then the previous header. Okay, previous header is okay IP header. Then before that, okay, before that we have the TCP header. TCP header. I write TCP header. Then we have the data. So this is what we have now. This is called the frame. Then Ethernet trailer. Okay, that means at the end you have to add the trailer. The end. In the beginning and the end, we have to add the Ethernet header and trailer. Now I have this is called the frame now. Okay, or if you want, I will make it in a very simple way, very easy way, so that you can understand. I will do it only for the data link layer. You can understand. See, let me insert a table. Then you will easily you can understand. See here. Now, see this. This is your data. Okay, this is the data what you have in the application layer, presentation layer, session layer. So this is coming to the next layer. The next layer is a layer 4. It is the TCP header. Okay, TCP header is added. Then it comes to the next layer. The next layer is a network layer, that is the IP layer. So IP header is added here. Now it is coming to the data link layer. So in the data link layer, I'm going to add Ethernet header. I'm going to add Ethernet header. I'm going to add. Okay, now, so what I'm going to do means Ethernet header. Okay, sorry. Wait. So just remove this. I'm just trying to remove this. Wait. Okay, leave it. Now, see, this is the Ethernet header, IP header, TCP header, data. So this is called the header. The first part is called the header. The remaining everything, it is called the payload. This is called the payload. Payload means like data. Okay, so this is coming from the previous slides, sorry, previous layers. Okay, this is coming from the previous layers. So what I'm going to do means, I'm going to encrypt this entire red color, I'm going to encrypt. So in the data link layer, so what you can encrypt means, you can encrypt the payload. Okay, see, payload of the frame are encrypted or authenticated in this layer. This is called the payload part. So this is given by the previous layers. This is not from me. So what I included only the header, Ethernet header. So except this, the remaining everything will be encrypted. So if you have data link layer encryption, in the data link layer, you can encrypt the payload path. What is available in the payload path? This is available in the payload path. Okay, so very easily we can do it. Okay, no need to do any changes. Deploying cryptographic algorithms at the data link layer also does not require any modification to the existing applications. So we know that the frames travel only on links, only one link. So traffic analysis, okay, this is all different things. So we can encrypt it. Okay, this particular part you can encrypt it. This is the point. Now, let me go to the previous slide. You can see. So in the network layer, so what you can encrypt here? Okay, you see. The payload of the IP packet or the entire IP packet itself, you can encrypt. Okay, what is the payload? You can just copy this. Okay, I'm just copying this. And I'm going to do the changes here. Now you can see I am in the network layer. Okay, this is the network layer. So in the network layer, okay, we no need to have the Ethernet because this is the thing. And here, this is the header and this is going to be the payload. So header, I'm going to change the color now. Okay, let me change the color. Now you can see this is the header and these two things I'm going to receive from the previous, okay, from the previous layer I'm going to receive. So this is the payload. Okay, TCP header plus data is the payload. So only this I'm going to encrypt, IP header I'm going to include. So what your understanding means, in every layer, you can encrypt the payload part. You can encrypt the payload part. What is this payload? Payload is nothing that what you are going to receive from the top. Okay, from the previous layer. Okay, whatever you are receiving, that is going to be your payload part. So the payload part we are going to encrypt here. So the TCP header and data will be encrypted. So IP header you are going to include, give it to the next layer. In the next layer, we are going to encrypt everything together. So this is the way you can do the encryption in the layers. There are some protocols available. Some protocols are available for doing this. We are going to cover, okay, it will come in our course. Okay, slowly we will study about this. So this is about how to implement the cryptographic algorithms. Okay, the cryptographic algorithms, you can have it in any layer, and every layer, the payload part will be encrypted. Okay, it will be implemented. Now, I'm going for the next one. What is that means? Implementation of cryptographic algorithms. This cryptographic algorithms, you can do it in the layers, or also you can do it in some hardware devices. Okay, in computer security, okay, we are going to study one lecture about the hardware security. Hardware security means in the hardware devices. In hardware devices also you can have, okay, you can implement this, okay, cryptographic concepts. Okay, and you can have it in the layers. In any layers you can have it. So cryptography can be implemented anywhere. Okay, anywhere it will be implemented. So whatever the data comes, so the cryptographic algorithms, okay, cryptographic algorithms, they are going to encrypt it. So you might have already studied about the cryptographic. There are two different types of algorithms available. Okay, one is the symmetric encryption, and second one is the asymmetric, okay, encryption, asymmetric. So in the symmetric encryption, okay, only one key will be used for both. But in the asymmetric encryption, you will be using two different keys, public key and private key. Okay, this is the concept. Okay, so this is what you have to know about the implementation of cryptographic in different layers. Okay, so this is what we are studying in this particular slides. Now, I'm moving to the next one, addressing. Protocol addressing. So if you take protocol addressing, three different types of addressing is very, very important. Okay, protocol addressing. What are the three types means? I already explained to you. One is the IP address. Second one is the MAC address. And third one is the port numbers. Okay, and port numbers. So these are the three important addresses, okay, as far as the networking is concerned. Okay, now you can see here protocol addressing. In protocol addressing, every computer, every device in this world, every device, your mobile phone or your PC or your laptop, okay, even your smart televisions. So every device need an IP address, then only they can connect it with the internet. So every computer in the network has an address. Anything, any device, smart devices. Okay, nowadays we are telling the IoT devices, Internet of Things devices. So for every device, there should be an IP address. Without IP address, this could not be connected with the internet. Okay, so teacher, I'm not giving any IP address to my mobile phone. Okay, you are not giving any IP address to your mobile phone, but still your mobile phone is connected with the internet. Okay, still your mobile phone is connected with the internet. How? From where this IP address is coming? Means the IP address is provided by your service provider. They are called internet service provider. If you use Omantel, Omantel will assign an IP address to your device. Okay, automatically it will assign an IP address to you. So using that particular IP address, okay, your device is connected. So you can see the diagram here. So a sender device, okay, through the internet wants to connect with another user. Okay, you take, this is myself and this is you. You are in a different place. So from my device, I'm going to connect with my ISP, Omantel. Then through the internet, okay, your ISP, maybe you are using a different, suppose if you are in a different country. Okay, please assume that you are in different country. I am in a different country. I'm in Oman, you are in some other country. So through the ISP in Oman, I'm connecting with the internet, and then the recipient ISP, okay, that means the country you are living, from there, okay, you are going to be connected. So what we are understanding means, so internet service providers plays a major role. Internet service providers plays a major role in assigning the IP address. Then, so the ISPs automatically they are giving, okay, an IP address to you. Then also they are going for the routing. So inside the internet, there will be so many routers will be available. So from here, my packet will go to the ISP router. From ISP router to the next router, next router, next router, you will be having collection of routers. This is called hop, 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 jumping. So from one router to router, okay, don't think only one router will be available. No, there will be plenty of routers available. We don't know exactly how many numbers. Every time your packet will go in a different route. Okay, that is called the route. So your packet will move in different routes, in different ways your packet will move, and finally it will reach the destination. That means the recipient ISP. From the recipient ISP, the packet will be delivered to the destination. So the protocol, sorry, the address, IP address plays a major role here. As far as networking is concerned, network security is concerned, you have to concentrate more on layer 3. Okay, layer 3. Layer 3 means networking layer. So in the networking layer only, okay, all the routing concepts are happening. Now, if I go to the, okay, you can see application. This is what we have done in the previous slides. Application layer. So your data is available here. Then your data is going to the next layer. The next layer is the transport layer. The two important protocols which are running, okay, in the transport layer is TCP and UDP. Okay, I'll just show you the previous slide, okay, where I inserted, you can understand easily. See here, application, presentation, session, okay, your data. So transport layer, in the transport layer, okay, it is converted into segments, port numbers are used. This is very, very important. Port numbers are used. So what are the two protocols? The two important protocols here is TCP protocol and UDP protocol. So these are the two major protocols available in the transport layer. So in the next layer, we are going to use the IP address. You can use either IPv4 or IPv6. Anything we can use. So what are the two protocols here? The two important protocols in this layer is either IPv4 or IPv6. These are the two major protocols running in this layer. Then in the data link layer, we are going to use the MAC address. So here the MAC address is 48 bits. There are so many protocols running. Okay, here the popular is Ethernet. The popular protocol is the Ethernet protocol. Okay, Ethernet is a very popular protocol. So this is about the addressing. You must very clear about this addressing. In which layer, okay, which address is used. What is the length of the address? Okay, so that is very important one. You can see this slide. Okay, so this is what I explained in this particular slide. So IP and others. So this is going to be layer 3 and this is layer 4 and this is layer 1, 7, 6, 5. Okay, they merge together. So this is about the layering concepts. Now, the next one is still we are going to continue with the addressing. So this address assignment means IP address assignment. Okay, we'll focus on IP address now. How you can assign an IP address means there are two methods available. So the first method of assigning the IP address is static method. Static method of assigning the IP address. What is static method? So you go to the machine, okay, you can go to the settings and you can change the IP address. Okay, we will see in the lab part. So you can change, statistically you can fix some IP address. Okay, I'm going for a machine, I'm going to enter, okay, the IP address 10.0.0.1, subnet mask, okay, then default gateway. So all these things I can enter manually. So that is going to be the static configuration or static method. What is a dynamic method means? In the dynamic method, you can use some protocols. Some protocols we can use. For example, the very popular one is DHCP protocol, Dynamic Host Configuration Protocol. So you can have a server, a DHCP server you can have. So using the particular server, you can assign the IP address to anyone. Okay, to any machines. Okay, you can assign the IP address by using the DHCP. So this is called, okay, the second method, which is called the dynamic method. Okay, so the two ways of assigning the IP address. One is the static and second one is the dynamic. Actually, static, if you have less number of computers, if you have only 10 computers, 20 computers in your network, you can use it. You can use static. Static will be easy. But if you have more, okay, you take our college. In our college, we have around 10 labs, okay, 10, I think more than that. And we have, every lab is having, okay, around 25 to 30 computers. So totally we are having around 500 hosts, 500 computers. So for the 500 computers, manually you cannot assign the IP address. Okay, manually we cannot keep the IP address. We cannot assign the IP address. So what you can do means you can use a DHCP server. So the DHCP server, okay, using the DHCP, easily you can assign the IP address to everyone in the network. Then, this is the two methods how we can assign the IP address. Then, the next is who assign the address? Who assign the address? Who is going to give you the address means this is going to change depending upon the place. If you are inside your college, okay, if you are inside the college, the IP address will be given by the administrators. If you are using a mobile phone, I'm using a mobile phone, okay, I'm outside the college, I'm just connecting with the internet means your ISP will provide it. Your internet service provider will assign the IP address to you. So depending upon the place, okay, depending upon the situation, so where you are, in which network you are, okay, in which network you are. So based on that, the IP address will be assigned. Okay, you can see there are three different entities. One is the central authority or ad hoc or locally based. So there are different authorities available, different entities. Okay, it's not going to be same. If you are in the college you can have a locally based. So ad hoc means, okay, if you're using a mobile phone, something like that, you can have it. Even in your home, if you're having, what is that? If you're having the internet access points, okay, internet access point if you have, so automatically your internet access point, okay, that means the device you have in your home, it will assign the IP address to you. Okay, you can fix it. You can go and configure, automatically it will assign the IP address. So depending upon the place, okay, depending upon the network you are connected, so based on that, okay, that means the IP address will be assigned. Okay, so this is the thing. Now, next one, physical address, IP address. Already we discussed about this. So IP address, it is layer 3. Layer 3. So this is global address allocation. And this will be done by using the DHCP. By using the DHCP, you can assign the IP address, and also static you can give static IP address. This is what we discussed in the previous slide. So by using the DHCP or by using the static method or locally controlled means by using the ISPs. Even ISPs they can provide, or if you have your own Wi-Fi network, okay, you can control that by using your devices. Okay, so depending upon the networks. So this is about the IP address. Now, go to the physical address. So physical address means this is otherwise called MAC address. Okay, so this is otherwise called MAC address. That means this is available in layer 2. Layer 2, and the length is 48 bits. Now, this address, who is assigning this address means this address is assigned by the vendors. Vendors means the organizations or the companies. I'm having a laptop. My laptop is having a MAC address. Yes. The length of the MAC address is 48 bits. Yes. Can I change this MAC address? Means no, you cannot change. You cannot change. I'm using laptop. My laptop is having an IP address statically. Okay, I fix statically. Can I change this IP address? Means you can change. You can change. IP address you can change, but a MAC address you cannot change. It's fixed. If you are having a mobile phone, so for a mobile phone also the MAC address is available, but we are going to say it is as IMEI. Okay, IMEI number, International Mobile Equipment Identifier. So this IMEI number, can I change this for my mobile phone? Means no, you cannot change. So this MAC address, whenever you buy a device, okay, a PC, computer, or a laptop, or a mobile phone, so this MAC address is fixed by the vendor. Vendor means the company who is producing that. Okay, it is fixed. Can I change this? Means you cannot change. You cannot change. You cannot change this, but IP address you can keep on changing. Okay, so this is the vendor assigned. In which layer it is available? Means it is available in the layer 2. Okay, I don't want to go more here. There is a device, there is a card, network interface card, NIC. So the network interface card is used, okay, in the layer 2. In the network interface card only, okay, you will have the MAC address. So the MAC address is burnt. It is fixed by the vendor. So vendor means the company who is producing that. Okay, they will fix your MAC address and they will give it to you. Now, so using the MAC address, you can have some filtering concepts we are going to discuss in the lab part. Okay, and you can use the MAC address to get your IP address. Okay, to get the IP address, you can use a MAC address. But what is the point here? Means the MAC address cannot be changed. Okay, it is fixed. It is fixed in the layer 2. Okay, layer 2 of a device. In the second layer of a device, it will be completely fixed. Now, next layer is port numbers. So port numbers we already discussed. Okay, the port numbers are used in transport layer. Teacher, here it is written as application layer. No, it is not application layer. It is application address. See that. This is application address. So in which layer it is available? Means it is available in layer, okay, layer 4. What is the length? Length is 16 bits. 16 bits. Okay. So about these port numbers, so it is not very clear to me, teacher. Can you explain? Yes. So 1 minute. I'm just taking now to see. I'm having a computer. Okay. So this is my system. So this is my system. Now, for this machine, I'm going to fix a IP address. Okay, I'm going to fix a IP address for this particular, okay, machine. Okay, so I'm going to have a IP address. So let the IP address is 20.0.1.1. Okay, so this is the IP address of this machine. Then, for this machine, already a MAC address is available. Okay, a MAC address is available. I'm not giving the MAC address. So the MAC address is fixed in the layer 2. So for example, this is the MAC address. Okay, so the MAC address will be like this in this format. So this is the MAC address example. So the MAC address will be available in the hexadecimal format. Okay, hexadecimal format from 0 to 1, sorry, 0 to 9 and A to F. Then for this machine, I need a port number. I need to give a port number. So can I give any port number means no. You cannot fix any port number for this machine. You have to fix the port number based on the service running here. Okay, for example, this is a website or this is a web server. Okay, for example, this is a www.sissuite.com. This machine is having this particular website, and this is the name of this particular machine. This is the host name. So this is a website. Okay, many people, they want to access this site, this machine. Now, what is the port number I have to fix means the port number for this machine I have to fix port number 80 I want to fix. Okay, what is this 80? 80 says what type of service running in this machine. What type of service is running in this machine? So here this machine is a web server. It is a HTTP server, a web server. So for this machine, I have to fix the port number as 80. Suppose if this machine is a FTP server to transfer only the files. Okay, I'm writing here. Suppose this machine is having all the FTP, that means files for the students to transfer, FTP server or FTP machine. This is a FTP server, file transfer server means I'm going to change the port number. The port number is going to be, the port number is going to be 2021. So 2021, okay. You can have either 20 or 21, but meaning, some different meaning is available. Keep it, 2021. So what is this means? What type of service running in this machine? So based on that, you have to fix the port numbers. So port numbers, you cannot fix just like that for a server machines. Okay, this is my machine. Okay, you see, this is my machine. I'm sitting in this particular machine. Okay, this is my machine. Okay, I want to access this machine. Okay, I want to access this machine. I'm going to access this machine. Now, for my machine, what are the IP address? Okay, now you see, I'm going to have a IP address. For example, 10.0. Okay, I'll take another one. So 11.0.0.1. This is my IP address. And my MAC address, okay, let it be, this is my MAC address. Okay, this is my MAC address. Okay, it is like this. Then I want to use a port number. For my machine, there should be port number. What is the port number I can have means, for my machine, no need to give the port number like this. You can choose, that means your machine will automatically choose because you are a client. Okay, so you can choose, or your machine will choose any port number, okay, from 49151, okay, to 49152, I think, 52 to 65535. From this range, automatically 65,535. From this range, automatically it will choose a number for you. Okay, so this is the concept. So if you are going for a server machine, your port numbers, the port numbers must be from 0 to 1023. Okay, if you want, I will write it here. 0 to 65535. This many port numbers available. Okay, totally. Okay, totally. This many port numbers available. 0 to 65,535 port numbers available. In this 0 to 1023, 0 to 1023. So this is called well-known port numbers. Okay, this is called well-known port numbers. So well-known port numbers means this is fixed. 0 means for this, 1 for this, 2, 3 for this. So up to 1023, it is already fixed. Okay, 80 means web server, 2021 means okay FTP, 23 means okay telnet. So like that, it is already fixed. You can search it in the internet. You can just search it in the internet. Well-known port numbers, you will get the list, complete list you will get. Okay, complete list you will get. So this is called well-known port numbers. Then the next port number from 1024 to 49151. Okay, so this port numbers is called registered port numbers. Okay, this is called the registered port numbers. So these port numbers are registered by some organizations. Okay, it is already registered by some people, so we cannot use this. Now, the remaining thing 49152 65535. This is called okay dynamic port numbers. So the users for your machine and my machine, okay, my machine and your machine will select the port number automatically from this. Okay, this is a very important thing for a networking student. You must know this very clearly. Okay, see. So this is our college web server. I am going to fix the port number for this 80. It is well known. But this is my machine, okay, or your machine. You are going to access the web server means you can use any port number from this range. Okay, your machine will automatically take. Okay, it will automatically assign okay the port number for you. So this is about the entire thing about the port numbers. Okay, it's a very important thing. So you must know all these things okay regarding the port numbers. So I'll make summary. Okay, just I'll summarize the three things. IP address, okay, IP address, MAC address, and port number. So MAC address layer 2, this cannot be changed. It is fixed. IP address layer 3, layer 4 port numbers. So regarding the port numbers, this many things are available, different types of port numbers available. Okay, so this is about the overall thing. Okay, now, okay, I need to know, okay, is it clear? Is it understandable? Are you with me? Any doubts up to the next topic? So the next topic is a protocol headers. So this is the last topic in this lecture, protocol headers. So we already talked about the headers. Every layer is going to add a header. Okay. So if you take the TCP, that means layer 4. Layer 4 is adding its own header. Then layer 3 is adding its own header. Layer 2, okay, that means the Ethernet header is adding its own header. So every layer is going to add okay something with the data. That is called the header part. So if you want to just recall it, okay, you can see. I'm just bringing this diagram here so that you can easily understand. Wait. So every layer is adding a header. Okay, you can just see this. You will understand now. So TCP header, IP header, and Ethernet header. So about these headers, we are going to talk. Okay, we are going to discuss. Okay, now, if you take the header, what is available in the header means header is something like what to say, from where it is going, from address to address will be available. If you write a mail, I'm writing a mail. So what I have to fill? I have to fill from, then to. What is the subject? This from to is very important. Then only the mail will go to the destination. Same. The header will have some basic information, very important informations will be available in the headers. Okay. So these headers, okay, you can see the address and the protocol. Related information is encapsulated within the each headers with packet headers. So like source IP address, destination IP address, source port number, destination port number. Okay, you follow the mouse now. All of you see the mouse now. Here, source IP address, destination IP address. Here, source MAC address, destination MAC address. Okay. Oh, sorry. Okay, it's mistake. Here, source port number, destination port number. Okay, repeat. Okay, I'm repeating. TCP header, source port number, destination port number. Here, source IP address, destination IP address. Here, source MAC address and destination MAC address will be available. Okay, so every protocol will add its own data there. Okay, now these headers can come in two forms. There will be two different forms. What is that? One is called the fixed packet type, and second one is called the free form type. So the headers, if you take this TCP header, if you take this IP header, Ethernet header, so these headers will have two forms, two different forms. What are the two different forms? One is called the fixed packet type and second one is called the free form. Okay, now what is this? I'll show you some diagrams. You will understand very clearly. Now you can see I'm just going for the fixed. So fixed packet header. So what is the fixed packet header means? Everything will be fixed. That means the size and then the fields, everything will be fixed. So we cannot change. Okay, we cannot change. Okay, now you see here. This is the payload. Payload means the data. Then this is going to be the header. Okay, the header. That means this is fixed and this is option. So fixed means you have to give it. You cannot skip anything from that. Okay, you cannot skip anything. Okay, for example, you see addresses, layer addresses. Okay, like IP address. Okay, or Ethernet address, that means the MAC address, or the port number. So everything should be properly given here. So options means you can include or you can exclude that. So this will be optional fields. This is called the optional fields. And then payload. Payload is your data. Okay, this is the data coming from the first three layers. So this is the data and this is the header. In header, there will be some few options, but this fixed means this is compulsory, you have to enter. Okay, we are not going to enter. Automatically your system will create. Okay, your system will automatically fill everything. Okay, it will automatically fill everything, okay, in this particular header. But payload is coming from the previous layer, and options you can include or you may not include this. Okay, this is the optional one. Then finally, trailer. Trailer means it is used for error control, finding the errors. Okay, finding the errors. So if you completely, if you're not able to understand, you no need to worry about this, because in the lab part, if you see one particular one particular packet, you will understand all the fields very easily. You can understand. Okay, so this is about the fixed. Now I'm going for the theory part. You can see a fixed means a fixed packet where the fields are fixed in both the location and the size. You cannot change it. The size and the location is going to be fixed. You cannot change the location. Location means place. You cannot change the size. It is going to be fixed. But in the free form, what is free form means? In a free form, a header where the data is not a fixed one, it is not going to be fixed. So in the free form, header are usually present at the application layer, but the data flow is a stream of data and not a series of packets. So this can be changed. The headers can be changed. The place can be changed. The size can be increased. The size can be decreased. Okay, in the free form. Okay, now you can see, I will show the free form. So in the free form, you see there is no restriction. There is the header is started. Okay, what type of data? This is application layer 7 data is available. The length. Okay, I want to change the length. I'm going to change the length as 100. You can change it. I want to change the length as 300. Automatically the size of the packet is going to change. Then I want to change the encoding encoding technique they are using ASCII. So I want to go for, okay, some other technique, okay, EBSPIC. So I can change the name then. So the header is over. Up to this, header is over. If you want to change the position, I want to remove this, I want to put it here, you can do it. So the field, okay, the fields you can change. So this is called the free form. So in free form, the field header, okay, the field header can be, okay, the size can be increased, size can be decreased, okay, the fields can be freely changed, okay, it can be moved. But if you are going for the fixed means, you cannot do anything. So fixed means it is going to be fixed. All the fields will be available, okay. Just hold on 1 minute. I will show the fixed, okay, I will show the example for fixed so that you can understand very easily, okay. Layer B. 1 minute. I'm just showing you a diagram so that you can understand the fixed also. Yes. Now you can see here. I'll just show you a fixed one. So in the fixed one, you cannot change the place, you cannot change the length, okay, you cannot change anything, okay. All of you, can you see the IPv4 packet header format? Can you see that? Can you see the diagram I inserted just now? Kindly confirm, any one of you, yes or no? Audio.
Yes.
Yes. Now you see, this is called a fixed header. What is the fixed header? See, from 0 to, okay, 3, actually 4 bits. So this is going to be the version. I cannot move this to any place. Next one, you can see here, source IP address. So source IP address is this, okay, in this place. Can I move this source IP address above? Means you cannot. Okay, you cannot. Then I have time to live. Time to live is 8 bits. The length is 8 bits. Can I change this? No, you cannot change. You cannot increase, you cannot decrease. This is called a fixed header. You cannot change, okay, the order of this. You cannot change the size. So first one, 8 bits means 8 bits. Okay, you can see the flags. The flags is available here. Can I change the flag here? Means you cannot change. So this is called the fixed header. So in the fixed header format, okay, you cannot move, okay, the fields, you cannot change the size, okay, nothing. But in the free form, you can do it. Okay, this is called the free form. So in the free form, okay, you can do it. You can change it, okay, from anywhere to anywhere. You can change it. You can increase the size. You can decrease the size. Some fields you can remove. Okay, this is going to be the free form header. Okay, so this is the two different types available, okay, as far as the packet header comes. Okay, so in this lecture, what we discussed means, okay, we discussed about protocols, then we discussed about the standards organizations, what are the standards organizations available, then we discussed about the specifications, then we discussed about the layers. Okay, that means the OSI layer and TCP layer. Okay, what are the layers comparisons? Then cryptographic placements. You can keep the cryptography anywhere, in any layer. We discussed about that. Then we discussed about the addressing. The three important things. One is IP address. Second one is a MAC address. Then the third one is a port number. So we discussed about these three different types of addresses. Then we discussed about the headers. Okay, the major, there are three headers available. One is the transport layer header. Next one is the IP header. Next one is the data link layer. That means the Ethernet header. So about the headers we discussed. So these headers, there are two different forms. One is the fixed form and second one is the free form. So in the fixed form, okay, the place, that means the location, size of the fields, okay, of the fields are fixed. You cannot change it. But whereas in the free form, you can do some changes in that. Okay, so this is about the protocol headers. So this is what we discussed in this particular lecture. So with this, we are completing lecture number 2. Okay, So thank you very much. I will upload the video. Okay. So in this weekend, okay, I will upload it. So thank you very much. In the next week, we will start the labs also. Okay. Lab also we are going to start.